Welcome to the Damon McMurdo Math Maniacs Math Network. Today, I'm going to do a couple things. One, I'm going to go over two problems from the what has a bottom at the top, just to be nice and helpful. And I'm going to go over two problems from the orange task cards. Now, some of you didn't do well on the task cards, and we're going to want to maybe work along with me. I did two of them, of the orange task cards, and two of the problems on what has a bottom at the top on the video this first class. So you may want to go back and watch that. I'm going to do two different ones today for the orange task cards in this class. I'll do two different ones in my third class. And then for tutorials, I'm going to do two different ones. So by the end of school, or by the end of the day today, before I leave, I will have done all 8 orange task cards and posted them on the tube of you. So anybody that does not get 100% on the orange task cards, that's on y'all. That's my copy. Don't mess with my copy. So some of you didn't get quite as good of a grade as you wanted on the orange task cards, even though you turned them in early. And that's fine, because they're not due till Friday. So follow along. Write down what you need to write down. Show work what you need to show work of. Then you'll have some time. Like I said, by the time I leave school today, I will have done on video and posted on the tube of you all 8 of the questions for the task cards between the 4 videos that we'll record today. So if you want a good grade, like right before Christmas comes and Santa drops off things at your house, you might want to have a good grade on the orange task cards, because 100 in the grade book would be nice. So Kyle, you got paper out? You're going to go over the orange task cards with me? Or are you happy with what you got? No? Good. If you have your bottom at the top paper still with you, get it out. I'm going to go over a couple of those problems as well. In the first class, I went over 16 and 17. So if you don't have 16 and 17 done, you can always look back at that. I also told the first class at number 21 the answer is 1/6. So on the bottom at the top, number 21 is 1/6 if you want to.
That one was really easy.
So let's do 18 on the bottom at the top, which is 3/4 times 4/3 times 5/5. That again is number 18. 3/4 times 4/3 times 5/5. I don't really have to do any math to solve this problem. Victoria, what is the answer?
A hole.
1 whole. 1 whole. Because the numerator is 3 times 4 times 5. The denominator is 3 times 4 times 5. So you're going to get an answer of 1. 1, uno. Because you're multiplying the same numbers across. And if your denominator and numerator are the same, it's actually 60, right? Yeah, it's got to be 60 over 60, which equals 1. So fairly easy. Didn't really have to do any math on that. On your notes, you could just say, duh. Fairly easy. I'm just saying. I'm only saying, just saying. All right, pick one.
13.
All right, now we'll do 13 on the bottom at the top. 13 at the bottom. You know what the answer is? What has the bottom at the top? Gunner? A leg. Because see your leg, and at the top of your leg is your bottom.
Oh, that makes sense.
So it has a bottom at the top. Your leg has a bottom at the top of your leg. Y'all with me here?
Yeah.
You get it?
Yeah.
Is it funny?
No.
Good, I thought it was too. 13. Is that what you said?
Yeah.
1/2 times 4/9 times 3/5. 1/2 times 4/9 times 3/5. I don't know, I said it a minute ago.
13.
Okay, 13 according to Victoria. 13 according to Victoria. All right, please remember you can multiply in any order you want to. Multiplication has that property where you can do it in whatever order you want to. Kind of like addition. Kind of like addition.
Multiplication is just addition.
Repeated addition. Except with fractions. Can you add 1/2 4/9 times? No. So, whole numbers you can. Whole numbers you can. All right, so this really isn't that difficult of a concept, multiplying fractions. You multiply straight across. Let's go 3 times 4 times 1 is what? Anyone? 12. And then I'd multiply 9 times, well actually I'd multiply 5 times 2, and that gives me 10. And 10 times 9 gives me 90. Now I'm looking on that paper, and Ricky, I'm not seeing the fraction 12/90ths on there. Why is that? It's not an improper fraction. But you're right, there's something needs to be changed with it.
Oh, I know.
Shh, Ricky will get it. Gosh, y'all have doubts in Ricky.
I'm working too. No, just like getting the answer right.
Awesome. It needs to be simplified.
Yeah.
Needs to be simplified. Needs to be simplified. So now, looking at this, Ricky, I need to find a number that will divide evenly into 12 and 90. Can you think of one? They're both even, right? So 2, good. 2 will divide evenly into every even number. So Ricky, what's 12 divided by 2?
6.
Okay, you're not Ricky, Ethan, you're Ethan.
Yes, I am.
Ricky,
Changing my name to Ricky.
what is 90 divided by 2?
30.
Shh. 45. Now I'm looking back at that paper where it should say a leg, and I'm not seeing 6/45 on there. Ricky, why am I not seeing it on there? It's not an improper fraction. It needs to be simplified. Good. So do you know of a number, Ricky, that will divide evenly into 6 and 45? 3. If I use my divisibility rules, the sum of the digits in the numerator is 6. The sum of the digits in the denominator is 9. 4 plus 5 is 9. That means it can be, since both of those are a multiple of 3, that means it can be simplified by 3. Ricky, 6 divided by 3 is? 2. And Ricky, 45 divided by 3 is? You can do it on your paper if you want. No one's rushing you. No one's from the Soviet Union in here, though, so we're not rushing you. Shh. Work on your paper. Write it down on your paper. 45 divided by 3. Now, hopefully, if you haven't done these problems, you're writing down the work because you know you have to turn in all the work with your 15. Now, Ricky, is 2/15 on there? Awesome. Yes, it is. So you would shade in 2/15 if you've not yet turned in your bottom paper.
Can I turn it in now?
Well, not while I'm teaching, but thank you for asking.
Okay. You're welcome.
But you have to be able to show all your work for every problem.
Yeah, I do.
Okay. We did which one there? We just did 13. And I'm going to do number 9. Number 9. Seven fourths
20.
times 20. Thank you, Kayla.
Yay.
Kayla stood up, jumped up and down, raised her hand and said, please, let me do this problem. So Kayla, I'm going to let you. So I have 7 fourths times 20. So what do I need to do this? Well, I got to do something because I have a fraction and a whole number. It's right here. It's right here. It's after number 8, which makes it number 9. Excellent. Kayla says I have to change. Shh, we're quiet. We're quiet. Kayla says I have to change 20 to a fraction. And how do I change 20 to a fraction, Kayla? I put it over 1. Awesome. Because every whole number can be changed to a fraction just by putting it over 1. Because all a fraction is a division problem. 20 divided by 1 equals 20. Get a pass if you need to go. 20 divided by 1 equals 20. So that's what... And so 20 divided by 1 equals 20, and there's 20 there. Yes?
I'm pretty sure you can just keep the 20 and multiply the 20 by the numerator, then you get your
Yes.
numerator.
Yes. Yes. All right, so Kayla,
Yeah.
what is numerator times numerator equals what? 7 times 20 equals?
140.
140.
140.
And 4 times 1 equals 4. What type of fraction is this?
Improper.
Improper. How do I fix an improper fraction, Kayla?
You simplify. Divide.
I'm going to divide. So, what goes on the inside of our division part?
140.
140. So, our numerator is our dividend. And my divisor is? 4. How many times does 4 go into 1, Kayla? No. Does 4 go into 14? So I'm going to have a 2-digit quotient. I don't know about a remainder yet, but my quotient is going to be 2 digits. How many times does 4 go into 14, Kayla?
3 times.
3 times. And Kayla, 3 times 4 is?
12.
12. And Kayla, 12 from 14 is? 2. Okay? And since after I subtract it's smaller than my divisor, I'm in good shape. I bring down my 0. And Kayla, how many times does 4 go into 20? 5. There is no remainder, so my answer is just the whole number 35. I wouldn't say 35 and 0 fourths. It's just 35. So I have done those 3 problems, which means I've done 1, 2, 3, 4, 5 of the 21 problems and given you the answer to the 6th. So you should have 6 of them done correctly. Yes, ma'am.
Can I do the next one?
Well, the next one, yes. But now we're moving to the orange cards. In my first class, I did problems 1 and 5. So if you want to see the answers and the work for problems 1 and 5, watch the video. I think it's titled something like December 6th, 2017, Class 1 or something like that.
That doesn't really
Something like that. I'm going to do 2 different ones during this class. So let's try first number 6.
Okay, number 6.
Number 6.
Now, one thing I found when grading them, I want the answers in the correct order. So just because I'm doing 6 up here, even if you haven't started, don't put your answer to 6 and then jump to 3 and then jump to 1 and then 5. No, write them in order. You can show your answer and how many, whatever row you want to. But please write the problem when you're answering it in the correct order, because I don't like to do a scavenger hunt when I'm finding it. All right, so next. When? You all right back there, Jake?
Yeah.
Okay. On these orange cards, they write the problems horizontally. So number 6, written horizontally, says 2/3 subtract 4/9. Victoria, which one of those 2 fractions is greater, 2/3 or 4/9? 2/3, good. Because I couldn't take 4/9 away. I mean, you can, but you're going to get a negative number. We don't want to do that, so we're not at that point in our lives yet. That's a horrible seat for you. Yeah. So, instead of writing it horizontally, we're going to... Victoria, what is this called when you write it this way?
No.
Yes, vertically. Good. So we're going to have 2/3 subtract 4/9. Now, Victoria, can we subtract these the way they're currently written? No, why not?
Because you can't divide the denominators because they're different.
Good. So we cannot subtract or add fractions if they don't have a common denominator. So hopefully if you haven't done this, you're writing this stuff down.
Can I sell my pencil?
So, Victoria, I need to find my least common denominator. Victoria, what are my 2 denominators?
9 and 3.
9 and 3. To find the least common denominators, I could turn to my multiplication chart. Or I could just list my multiples.
Yeah.
I always like to start with the smaller of them to see if the bigger denominator is a multiple of the smaller. So list my multiples of 3 for me.
6,
Okay.
9, 12, 15.
Do I have to keep going?
No.
No. Because 9, Kyle, you with me? Because 9 is our least common denominator. Which means I need to change both of these fractions so that they have a denominator of 9 without changing the value. So, is either one of them fine the way it's written? Which one?
Wait, what?
Do either one of these already have a denominator of 9?
Yeah.
Yeah, 4/9 can stay 4/9. This one does not have a denominator of 9, which means I need to multiply it by a fraction that equals 1, because if I multiply by 1, I don't change the value. Victoria, what would I multiply by here?
3.
3/3. And I know that because 3 times 3 gives me 9. So my numerator, 2 times 3, is going to be what, Victoria?
6.
6. Now I go back and I look. This is a subtraction problem.
I lost my pen.
Victoria, 6/9 subtract 4/9 is
2 9.
2/9. And this one cannot be simplified. The greatest common factor for 2 and 9 is 1. So that was problem number 6. Did you write anything down, Kyle? Yeah, I would have wanted to write it all down so you learning. Yeah. I'm just saying.
We do 8 next.
You want to do 8 next. So I want to do an addition one. I just did a subtraction one.
Okay.
So I want to do an addition one. Let's try number 3. Number 3 is 3/12 plus 2/3. 3/12 plus 2/3. We want to find the sum of those two numbers. I think it's number 3.
Okay.
I could be wrong. Let me know what you think, America. 3/12 plus 2/3. Nasir, can I add these two fractions the way it's currently written? No. Why not, Nasir? The denominators are not the same. They're unequal denominators. So I need to find the least common denominator of 12 and 3. Nasir, what is the least common denominator of 12 and 3? 12. So I need to change these so that they're both have a denominator of 12. Nasir, does one of them already have a denominator of 12?
Yes.
Yes. So 3/12 stays just like it is. Does the other one have a denominator of 12, Nasir?
No.
No. Which means I need to multiply this by a fraction that equals 1. And any fraction that has the same numerator as denominator equals 1. So what fraction should I choose, Nasir? And this one we already did. So it's this one we're doing. Sorry. He confused you, Nasir. 3 times what is 12, Nasir?
4.
4. So I have to multiply this fraction by 4/4. So Nasir, what is my new numerator?
And
No, that's my denominator. 2 times 4 is?
8.
8. Nasir, is this an addition or subtraction problem?
Addition.
It is addition. Nasir, 3/12 plus 8/12 is 11/12. Can that be simplified, Nasir?
I don't think so.
No. The only factors of 11 are 1 and 11. And 11 is not a factor of 12. So now, between the 2 videos I've done today, I've answered problems 1, 5, 6, and 3. 1, 5, 6, and 3 of the orange cards.
They look like orange chicken.
Boom! Shakalaka! Peace out! God bless! Love ya! Do something kind!